चलिए. Okay. So once again, let us move and see how it actually being done in the lab. So look at this video. Is it visible?
Yes, ma'am.
Okay.
Yes, ma'am.
So this is how actually you would have done if you have taken this practical in the lab.
Verification of Archimedes' principle. Archimedes' principle states that when a body is totally or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. That is, when an object is immersed in water, it feels lighter. The buoyant force does not depend on the weight or shape of the submerged object, only on the volume of the immersed part of the object.
Is this part clear? It doesn't matter what is the shape
Yes,
of the
ma'am.
object. The volume is important. Okay.
Archimedes' principle can also be applied to an object of density greater than that of the liquid. If the density of the object is greater than that of the fluid, the
See, this is very well defined in this.
object will sink.
Look at the
If the
value of
density
density.
of the object is equal to that of the fluid, the object will neither sink nor float.
1 each.
If the density of the object is less than that of the fluid, the object will float. Aim. The experimental verification of the Archimedes principle by immersing an iron block into tap water and saturated salty water. Materials required: iron stand, spring balance, iron block, wooden base, digital balance, water, overflow can, 200 ml beaker, salt, glass rod, and spatula. Procedure: hang the spring balance from an iron stand and note the reading of the spring balance.
See, it is at 0.
Place an overflow
Because
can
initially
filled
it
with
should be at
water
0 when
on
there
the
is no
wooden
weight
base.
hanging on it.
Now, hang the block from the spring balance and again note the reading of the balance.
This is the
Place an
mass of
empty
object
beaker
in
on
air.
the digital balance. Note the reading of the digital balance. Adjust
Note
the
it down,
object holder on
97.8
the iron
grams.
stand to bring the spring balance with the suspended iron block down into the overflow can. Immerse the block fully in the water. Weight of the water displaced from the overflow can to the beaker is equal to the loss in weight of the
Now
block
this is
in
coming out to be
water.
101.3.
Note down the reading of both the spring balance
The pointer
and the
has moved
digital
up.
balance. Calculate the loss of water and upthrust using the formula. Loss in weight of the body is equal to mass of block in air minus mass of block in water multiplied by acceleration due to gravity. Upthrust is equal to volume of block multiplied by density of water multiplied by acceleration due to gravity. Preparation of saturated salty water.
So how do you make saturated salty water?
Take 200 ml water.
Remember
in a
what is
beaker.
saturated salty water?
Put
When
some
there is
salt
no
in the
more
water
salt can be
and
added
stir
into
well.
it.
Yes, ma'am.
Continue to add salt
at a given
till some
temperature.
salt is
Yes,
left
at a given
undissolved in the
temperature.
water. Make sure that you stir the water well after each addition. Fill the overflow can with prepared salty water. Place it on the wooden base. Place an empty beaker on the digital balance and note down the reading of the digital
Again it will be
balance.
97.8.
Hang
You
the
are using
iron
the same
block
beaker.
to the spring balance and note its reading as well. Adjust the object holder on the iron stand to bring the spring balance with the suspended iron block down into the overflow can. fully immerse the block in the salty water. Salty water displaces from the overflow can into the beaker. Note down the reading of both the spring balance and the digital balance. Calculate the loss of water and upthrust using the formula. Loss in weight of the body is equal to mass of block in air minus mass of block in salt solution multiplied by acceleration due to gravity. Upthrust is equal to volume.
Okay,